Today we are going to solve this problem 1.3, which states that find the angle between body diagonals of a cube. So here you can see that we have these two diagonals, body diagonals, this one and this one. So first of all, I want to find this diagonal, which is you can write it as a prime a, and to find out this vector, or you can say vector a, I have to solve this in this way that x2 minus x1, x unit vector, plus y2 minus y1, y unit vector, plus z2 minus z1, z unit vector. So here in this case we have x2 is 1, so 1 minus 0. Here as you can see that this is x2, y2 and z2, and this 0 0 1 is our x1, y1 and z1. So I can write in this way: 1 minus 0, and z2 is 0, z1 is 1. So we have this condition. So for vector a we get x unit vector plus y unit vector minus z unit vector. Similarly, for vector b, my x2, y2 and z2 is 1 1 1, and my x1, y1 is 0 0 0. So I am going to write it 1 minus 0 x unit vector plus 1 minus 0 y unit vector plus 1 minus 0 z unit vector. So I will get this x vector plus y unit vector plus z unit vector. Now I have these two vectors. Now we have to find the angle between these body diagonals. So this is the angle theta. So we are going to use vector algebra, that we can find out the angle between two vectors either by taking a dot product between them or taking a cross product between them. So we have an easy way of doing it, that I can take a dot product of the two vectors and it will give me the magnitude of A and the magnitude of B with cos of the angle between them. So we are going to use this equation to find out the angle between them. So we have first of all the magnitude of A and magnitude of B. So from this we can find out that magnitude of A is simply square of the x component, square of the y component, and square of the z component. In our case we have x component equals 1, y component 1, and z component minus 1. So 1 square plus 1 square minus 1 square. So this will give me 3 under root. Similarly, we can find out the magnitude of b, which is bx square plus by square plus bz square. And here bx is 1, so 1 square, by is 1, 1 square, bz is 1, so 1 square, and so that will give me again under root 3. Now the second thing is to take the dot product between these a and b vector. So for a dot b, I can write a dot b. So a is here plus y minus z dot x plus y plus z. So the dot product between two vectors is simply a dot b is equal to ax bx plus ay by plus az BZ. So by using this value, I can easily write so AX is 1, BX is 1, so I will get 1 plus AY and BY. So AY is 1, BY is 1, so I'll get 1, and AZ is minus 1 and BZ is 1. So 1 plus 1, 2, minus 1 will get 1. Now I'm going to use this equation, star equation, and put all the values that we have obtained. So from this equation we have 1 equals under root 3 cos of the angle. So from here we have 1 equals 3 cos of theta, or I can write cos of theta equals 1 by 3. So this is, or I can write it as theta equals cos inverse of 1 by 3. So this